Okay, so what I did, I turned on the computer. I don't know if I want to even, sometimes I don't think that computer shines up here that well. So if you don't mind, I got the computer on, but I'm just going to interpret this for you. So what I did was I went to the very last section, which was inequalities in 2.4, and I went to the last problem. And this almost doesn't look like an inequality. It says a large hardware store's monthly profit is this, 6.20x minus $10,540. It says its profit is this, 6.20x minus, whatever I said, $10,540. This is just the last homework problem, the profit. They gave me the profit for selling PVC pipe. X is the number of feet of PVC pipe that is sold. What level of monthly sales is necessary to avoid a loss? Well, okay, so you know to avoid a loss, what do you have to do to avoid a loss?
Profit equal to 0.
Your profit equals 0. Now the truth is, let's see. Right, if your profit is less than 0, you have a loss. If your profit equals 0, you broke even, is the phrase. And if the profit is greater than 0, then you have a profit. Or you've avoided a loss. Yeah, I don't know. I'm up here in section 2.4, and I just feel like they want me to do an inequality. Anyway, so this is a little strange. You're right. I feel like just setting this equal to 0. But the truth is, to avoid a loss, maybe I should set this, maybe I shouldn't set it equal to 0. Maybe I should, I want it to be greater than 0. I think that avoids a loss. Or greater than or equal to 0. Perhaps that avoids a loss. A loss would be a negative profit. Okay. So it's like, I mean, really, but you know, whether you set it greater than or equal to, or even if you just do equal to, I mean, you're going to get the same number when you do this math. You're going to move the 10,540 over, you're going to divide by 6.20, and you're going to get the same number, whether it equals or greater to, you know, that's how we got to type it in the computer. So, what is that number? Anybody got a calculator? 1,700, thank you. So we got to sell more than 1,700 feet of this PVC pipe to avoid a loss. If we sell exactly 1,700, we broke even. If we sell less than 1,700, we have a loss. If we sell more than 1,700, we avoided a loss. How much should be sold? I'm just going to type in 1,700, and I got it correct. So for that particular question, you really didn't need to concern yourself with the inequality. I mean, I was trying to work it into the problem, but the computer didn't care. The computer wanted the number. They didn't even care about the inequality. They do on this one, though. This is also in 2.4, a little word problem. It says the new high-intensity headlights containing xenon gas have an expected life of 1,600 hours. Okay. All right, I'm trying to read this without shining it up there. 1,600, because a complete system costs 1,000, it is hoped that these lights will last for the life of the car. Oh, okay. Suppose that the actual life of the lights could be 12% longer or 12% shorter than the advertised expected life. Write an inequality that gives the range of life for these new lights. Wow. All right, so somewhere in there, they're talking about these new headlights. And then their answer looks like this. They want an inequality. Their answer, they've got it set up there. They got it less than or equal to something and greater than or equal to something. They got kind of a range of where they think that these headlights should last. Now, I read a lot of crap there. One thing they say is it cost $1,000. I think that's irrelevant. This is not about the cost. It's about how long they last. I think I read that they lasted 1,600 hours. But they didn't really say it like this, but they said, but I'm going to say plus or minus 12%. Because they said it could last 12% longer or 12% less than the advertised 1,600 hours. This is how long the headlights last. 1,600 hours plus or minus 12%. Again, they didn't exactly say it like that. I wrote it like that because that's what I read. 12% longer or 12% shorter. 12% of what, by the way? 12% of what?
12% of 1,600.
Thank you, of the 1,600. In fact, that might help to do that. All right, well then, cool, let's do this. What is 12% of 1,600?
192.
192. So it could be 1,600 plus 192, or it could be 1,600 minus 192. That's all this is. That's all this is. I'm reasoning it out here. Yeah. If I add 192 to 1,600, that would be 1,792. That would be the high end of my range. If I subtract the 192, that's 1,408. That's 1,408. That would be the low end of my range, and I guess I sort of have an inequality. It doesn't feel like I did an inequality. I just did some calculations. So this is a little bit of homework that I found that I don't know, I thought maybe you would want a little help with. Prior to that, there's I'm still looking at the 2.4 homework. I'm looking for a better one, but let's do another one here. I'm looking at this 2.4 homework with just inequalities. It's kind of easy. This one, it looks real easy. 5x plus 4 is less than 2x minus 5. Watch this. 5x plus 4 is less than 2x minus 5. Now, I guarantee you guys all know how to do this, and I bet you could get your answer. What's funny is if you read their directions, you could get confused. Their directions say to do this by graphing. I don't think anybody would choose that method, and I don't know if it's really a good method, but there might be a point I want to make here, so let's make this point. They say, let's do some graphing. Now, hold on, let's follow this a second. So in other words, you could think of this as a line. Now, I know it doesn't, but you could think of this as y equals 5x plus 4. I mean, there's no y equals up here, but you could think of it as y equals 5x plus 4. And if it is, then it's a line that has a y-intercept of
-4.
Actually, positive 4. Positive 4, and a slope of up 5 and over 1. So here's a picture of that line. Let's picture that line. What about this line? This line has a, if you thought of it as y equals, this line has a y-intercept of -5 and a slope of 2. This one was up 5 over 1. This one's up 2 over 1. Damn it. Wow, okay. Now which one? Hang on. What's the damn question? And I got these curvy lines up here. Sorry, they're not supposed to curve. The question is, visually, see, here's what they're saying. You can look at this visually and say, when is this line less than this line? Visually. In other words, when I say less than, I think I mean below. When is this line below that line? Wait a minute, this line is the one with the big slope, 5x plus 4. When is this line below the other line? Right now, I think it's higher than the other line. When is it below the other line? Over here. I think this line is below the other line when x is less than this number. Whatever this number is, negative something. I can't tell what it is with my crappy graph. Maybe I should just do some math. How, you wouldn't do this inequality like this. I'm trying to explain the computer's directions a little bit here. You would do this inequality like this. You would subtract the 2x. Is that what you would do? Hello? Subtract 2x?
Yes.
Subtract 2x, that would be 3x. I think I would move the 4 over. That means I'm subtracting 4. That would be negative 9. Subtracting 4. And then I would divide by 3. So x would be less than negative 3. My picture sure doesn't look like that. But apparently that's a negative 3. And when x is less than negative 3, that's the answer. My picture sure got distorted with my curvy lines. All right, so you don't really do these things graphically, but I wanted to point out that you can think like that sometimes, and we might want to think like that in the future. So sometimes I'm looking at a problem for future reference, but I can visually kind of look at an inequality as when is the graph less than the other graph, which means below the other graph. Okay. Yes, ma'am.
I have a question about, I don't know if we're allowed to talk about the quiz, but I think it's on the first problem.
Yeah. Yeah, I might take a look at the quiz a little bit. So hang on just a second. What about any homework questions? You got a question on? Anybody? I just messed around in 2.4 there. I didn't find, let me do one thing here. Look, when I think of 2.4, I did a couple word problems because I was worried you guys didn't like those word problems. But when I think of 2.4, I think of this inequality. You ready? And I didn't see anything exactly like this in the homework. But I think of this inequality. So, I mean, there was some of these in the homework. There were compound inequalities. It's like two inequalities at once, and I taught you how to do it. What I didn't see in that homework was anybody with a denominator like this. I like having this denominator. I think step one is to clear out this denominator. What would you do? Multiply by 3. What you learned about this kind of inequality is that there's sort of 3 sides. So you multiply this by 3, you multiply this by 3, and you multiply this by 3. In the middle, please actually don't multiply by 3. Your multiplication of 3 was for the purpose of canceling. And you're left with 4x minus 5. Over here you have a 12. You actually do multiply, and over here you have a negative 21. But that was a good first step to kill that fraction. Now what? You tell me.
Add 5.
Thank you. Add 5. Add 5. Add 5. Thank you very much. That's negative 16. That's 4x. And that's a 17. One more move. Divide by 4. Divide by 4. Divide by 4. Thank you. All 3 places and you're done. Your inequality answer is this sandwich inequality here. I call it a sandwich. X lives between these two numbers. X lives between these two numbers. And those are the two numbers that give you this original inequality. Sometimes they make me sketch a number line. I put a 17/4 up here. I put negative 4 here. I put a parenthesis and a bracket. Do you agree? Mm-hmm. And I maybe shade everything there. Maybe I use my interval notation where I put a parenthesis, negative 4, comma 17/4 and a bracket. Yep. So, this is good stuff. Basic stuff, though. What about 2-3's homework? Anything good in 2-3's homework? I guess we went over that pretty darn good. this stuff. Okay. Let me see. Can I pull up this quiz? Let me see if I can look at this quiz. Chapter 2 quiz. Let's see. Where are these guys? Quizzes. So there's an online quiz. You get an hour to do it. When you open it up, you got an hour, and it's only 16 questions, and that was interesting. And I think you said the first question. What'd you say?
On the quiz you said the class.
Oh yeah. Okay, we'll get to that. Okay, we'll get to that. So you guys haven't looked at this online quiz too much, huh? Any questions on the online quiz? When I walked in a few minutes ago, people said they didn't look at it much. I wish there was. I'm looking at the online quiz. There's several of these. I guess you got to get good at these. I like focusing on the word problems, but then there's these things. 10x plus 9y equals 135. 10x plus 9y equals 135. These are these systems of equations that aren't a word problem. Negative 5x minus 3y equals negative 60. Negative 5x minus 3y equals negative 60. I found this one on the quiz. Solve this system of equations. You know, the quiz is multiple choice, so there's 4 answers there to choose from, but I think I would just solve it. I think it's easier just to solve it and then try to shortcut it some way. I don't know. What would you do?
You can either multiply by 2 or by 3.
Okay, yeah, you either want to, you want to multiply by something, try to eliminate something. You don't want to do any substitution or you don't want to do that. You want to multiply by something to try to eliminate something. So he said I could multiply by 2. That would be good. That would give me a negative 10x. That'll help me eliminate x. Or I could multiply by 3 and try to eliminate y. It doesn't matter. I'm in a habit of trying to eliminate x, I guess. I don't know. Well, actually, I don't have a habit, I guess. I'm going to multiply by 2. The top equation, I'm not going to multiply at all. I'm just rewriting the top equation, but I'm multiplying this guy by 2. It's a negative 10x, it's a negative 6y, and it's a negative 120. Negative. And now, when you add these equations, that's the interesting thing. You're allowed to add them together. This is gone. That's a 3y, I guess. And that's a 15. And dude, you're done. Dude, you're done. Divide by 3, y is 5. And you're not done. You know, actually, on the in-class quiz, I did find people stopping here. Maybe I said you're done too often. You know, you're not really done. Of course, when you're solving these, you need to find both variables. So you got one variable, and you substitute it back in somewhere. One of the original problems, I don't care. I think I'll go to that top equation right there, and I'm going to plug in that y. If I plug in that y, then I can solve for x. I substitute that y in there, and I solve for x. Right. Yeah, some people didn't finish that for some reason on the quiz. That's 45. When you subtract, that's 90. This is pretty easy. Divide by 10. X is a nice number. These were nice numbers. Technically, the answer is the ordered pair, 9, 5. X is 9, y is 5, and it's like this ordered pair. This is solving the system of equations. Yeah. You know, a good multiple choice test has common errors as answers, you know, a good multiple choice test. So anyway, it's got a lot of similar answers. You got to find the right one. That's the right one. You guys okay? Boy, this is pretty easy. I mean, this is pretty easy. I mean, I say that. I don't know. Some of your quizzes were a little worse from last week. I'm gonna get to last week's quiz in a minute and give it back to you. But here's a little word problem. On last week's quiz, I made it tougher than this. On this online quiz, it's kind of easy. It says to find the number of units for break even, that you better set R equal to C. They tell us that. In other words, revenue should equal cost. We know that, but they're nice enough to tell me that on the quiz. Anyway, then they give me a revenue function. They say R equals 80x, and C equals, so that's my revenue, and my cost is 30x plus 163,000. 30x plus 163,000. And the question is, how many of these things should you sell? Which, by the way, that's X. How many should you sell or make or sell to break even? And they told us, when I break even, I should have my revenue equal my cost. So this is pretty easy. I'm setting these equal to each other and solving for X. Too easy, right, you guys? Divide by, no. Subtract 30, sorry about that, that would make it tough. Subtract 30, X, that's 50x equals this. Divide by 50 and we get an answer. Divide by 50 and we get an answer. 3260. Is that what you said?
Yes.
I feel like I need another zero. Maybe I'm wrong. 16,300 divided by 5. No, she's right. Okay, good. Thanks. 3,260. Easy. That's the number of units you should sell to break even, right? You know what I would like to do to make it a little tougher? Remember, I tried to tell you this story, and on your quiz last week, I did make that problem just a little tougher. Let me just say something here. What if I said this? Instead of giving you the revenue and the cost equation, pretend I didn't give you these equations. So you don't see that, I didn't give you that. Instead, I told you that I sell this thing, the selling price is 80 bucks. Well, then what's the revenue? If the selling price is 80 bucks, revenue is pretty darn easy. Revenue is the price times how many you sell. So the revenue is 80x. What if I told you about my costs and I said I have a fixed cost of $163,000, and I have a variable cost, or maybe I say the cost per unit, or maybe I even use the word marginal cost. All these are a fancy way of saying slope, in a way. What if I said that the variable cost or the marginal cost was $30 per unit? Was $30 per unit. So you've got these fixed costs and you got this $30 per unit, which is the slope. Could you write your cost equation? Again, you're not supposed to look over here. You're just supposed to use reason and realize, oh, that's a slope, which is the cost times X, times how many I build. But then I have these fixed costs, these initial costs. Maybe I call them initial costs or fixed costs of 163,000. That's my y-intercept. That's my y-intercept and my slope, and it's a linear cost equation. So maybe I write this up in some way where you have to come up with this. That is more interesting than just telling it to you. But we'll see. We'll see. Computer's acting slow. Here's one of these funny mixture problems. Let's try this. Let's try this. There's a little mixture problem here. I'm looking at your online quiz. I'm trying not to shine it up here in your eyes. And so I'm going to read it to you again. It says this chemist has two solutions that contain different concentrations of acid. So one is a 4% concentration, the other is 11% concentration. So I feel like I'm mixing these two things together. They said one of them was 4% and one of them was 11%. Those are the two things I'm mixing together. This 4% acid and 11% acid. How many cubic centimeters of each? By the way, that's the volume. That's cubic centimeters. Instead of gallons, it's cubic centimeters. How many cubic centimeters of each should the chemist mix to get 50 cubic centimeters of a solution that is 8.4%? Hold on, I just read this to you. The final solution they want to be 8.4%. So I'm mixing these two together to get this 8.4% stuff. What I like about these mixture problems is they usually have percents and then they have amounts. They didn't tell me this amount, I think that's X. They didn't tell me this amount, I think that's Y. But they did tell me the final amount. They said it was 50 cubic centimeters. So now I read this paragraph and wrote this picture. I think it helps my brain think and get organized. So, but now this problem turns into algebra. I got to set up two equations, two unknowns. But I can do that. The picture helps me do that. What I realize is all those amounts better add up. So that amount plus that amount better equal to 50. So just this simple amounts better add up. But also, when you take that amount times that percent, which some students screw this up. When it's 4%, you know to write 0.04, don't you?
Yes.
Okay. When it's 4%, you write 0.04x plus a 0.11y should equal this 50 times 0.084, I think that is. So then you have a system of equations to solve. It may not be that pretty. The numbers could be nasty here. How would you solve this one? I would substitute. I would move this x over here and quickly realize that y equals 50 minus x. Once I realize that, that gets substituted in for y. Right? Right? Solve quickly for y, substitute it in the other one for y. That's the best way to do this, I think. There's other ways to do it, but I think that's the best way. This is a 50 minus x. I substitute it in for y. What's that number? Anybody got that number?
42.
What'd you say? 42.
4.2.
4.2.
Oh,
Oh, okay. Maybe your decimal was off a little. Yeah, 4.2. Okay, thank you. All right, I'm going to try this. I'm going to distribute the 0.11. What's the 0.11? 5.5. Thank you. 0.11 times the x is negative 0.11x equals 4.2. When you combine these x's, you get a little negative 0.07x, I think. And when you move the 5.5 over, you get a negative 1.3. I don't think this is going to be the prettiest number, but here it is. It's 1.3 over 0.07. The negative signs cancel, and this is a positive number. What is it?
18.5. 57142.857.
Great. 18 point blah, 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 he said. That's what I heard. I'm going to call it 18.6 cubic centimeters around it. Cool. We're not done. That's the 18.6 centimeters of this stuff. To get y, I go back to the original equation. It's pretty easy. Y equals 50 minus x. So y equals 50 minus that, of course. So we've been solving these equations. That's 31.4 cubic centimeters. So that's the answer. Those two amounts. Yeah, good stuff. Good stuff. This quiz. All right, look, I'm looking at the last one of this quiz. The last one on this quiz says this. It says, the cost function is this. They gave you a cost function again. The cost function is 11x plus 170. Interesting. Where C is in hundreds of dollars. That's kind of confusing. C is in hundreds of dollars. So in other words, yeah, I don't like when they do that. I don't like that, but that's all right. It's in hundreds of dollars. So in other words, if we get an answer of 1, it's not $1, it's $100. If we get an answer of 150, it's not $150, it's $150. I mean, 150, 100, I think ends up being 15,000. I mean, you have to add a couple zeros to it. The answer is in hundreds of dollars. And their question is, how many items can be manufactured to keep the cost between $259,000 and $380,000? They want to keep the costs between, what were those numbers? $259,000 and $380,000. $259,000 and $380,000. See, I gotta get that hundreds. I gotta figure this out. I mean, what I wanted to do, here's what I wanted to do. I want my costs to be between those numbers. I want to set up an inequality. I want to say my costs should be between those numbers, less than or equal to the big number. You know, actually, because they said between, did they say between? Then maybe, then it gets a little picky. But then maybe I don't want to include this, you know what I mean? To be between, maybe I don't want to actually equal that. I don't think they care too much about that, to tell you the truth. I want it to be less than that number, and I want it to be greater than this number. So I set up one of these double inequalities, compound inequalities. If it wants to be between, then it's between. The problem is, though, if I start doing this now, it's wrong because the units aren't jiving. This is in hundreds of dollars, and this is actually in dollars. Divide out 100 from both of those, she suggested. She's right. That's one approach. Or, I mean, you got to adjust one of them. You're right. Divide out 100 from those numbers, and then it'll jive with this equation. You're right. Or, what's the other option? Multiply by 100 on this equation. I guess the whole equation by 100. That'll make it in dollars. See, these are dollars, and these are hundreds of dollars. I need the units to jive. Right, it's messing with me. I like what she said. She said, if this is actual dollars, divide out 100 or take off a couple of zeros and treat this as a $3,800 $100. Divide out a couple of zeros. I like that. Now it's 2590. And now this works. Now I can find the x. Yeah, I agree. Now I'm doing this problem. By the way, what do I do? Subtract the 170, subtract the 170, subtract the 170. That leaves me 11x in the middle. And that is 3630, I think. This is 2420. Divide by 11. I don't know if that's going to be pretty. Divide by 11, divide by 11. X lives between these two numbers. I think this is the number of things I should build. What are those numbers? What is this one? 220. Exactly? Oh, it came out exactly. 220. Well, that's nice of them. And this one? 330. Exactly, huh? Well, that's nice of them. I think we did this problem. We had to adjust those hundreds.